good evening, everyone. Sorry about the misspelling on, on the chat there. I wasn't paying attention what I was doing. But I hope everybody's having a good week so far. It's Tuesday, July 1st. Can you believe July 1st? Hey, Rick, how you doing? Yeah, July 1st and episode 101. This is, it's totally blows my mind that we've gone this far. But, you know, you guys keep coming, watching, and I keep doing it. So, I appreciate everybody, you know, spending their Tuesdays coming and listen to me run my mouth. And, you know, I try to put some good information out there. Hope, you know, you guys find it interesting. And, you know, if there's ever anything that you ever want to see that you don't think we've covered or something, you know, give me a shout out. Let me know. Hey, Mike, how you doing? Kind of got some stuff done this week. Worked on the, had to make a custom fan clutch spacer for the Olnick. That's not something I don't think you could ever find. It's not. I didn't get a spacer to space the clutch. I got a spacer to space the fan off of the clutch. You're right, Mike. You guys are my enablers. But yeah, so I got that done. Started working on the NASCAR, trying to get the new transmission in, new road race differential. I didn't get pictures, but I'll show next week. I got my electric lead melting pot out and made 100 pounds of lead ingots, 12 ingots, roughly 100 pounds. So for ballast for the car. And I got to get some tubing. We're going to move the battery box to the passenger side. So I'll show you some pictures of that next week. I got the oiling rig on for Leo's 4200 pretty much done. I got a little video to show you on that. Although rewatching the video, I have to make some adjustments. So we'll go over that in a minute here. So and then of course tonight is part 2 of welding. So I'm going to go over some MIG welding basics, equipment that you need. Unfortunately, I was pretty busy this week, so I wasn't able to get welding cassettes ordered on time to weld. So I just grabbed some scrap, and I have some door frames for my compressor house that I've never put together. So I went ahead and welded those. Hey Ryan, how you doing? So I guess first thing I want to show you guys is the spacer I built for the Olnick. Boy, it'd be nice to have a CNC machine and know how to use a CNC machine. I don't, and I have just a old school hand operated lathe and mill, and so I had to go ahead and do this thing. So what I was basically doing is making a spacer. So on the Olnick truck with the engine swap, we have the engine sitting in the same exact location as the 366 was. However, the water pump is obviously different. This is a serpentine drive setup, and it's made for a pickup truck, C25, C3500 Chevy truck, basically like a 2001 to 2008. So the water pump ended up being just in a little bit different position, and it put the fan really close to the radiator support. So I needed to move the radiator, the fan back, and so I made probably maybe one of the first ever spacers that goes between the fan and the clutch. So let me switch over here. So the outside diameter of the spacer ended up being about 4.5 inches, and of course the only 2 chunks of aluminum I had in the shop were 6-inch and 4-inch. So I had to take a 6-inch chunk and machine it down. Got it spot faced and indicated in the jaws, and then went ahead and started machining it. And then after a lot of cutting, I got the OD down to the size I need for the clutch. So this outer piece here is 6-inch, and this is a 4-inch 300, I believe, is what it ended up being. So that took a bit of cutting. You can see the spacer's a 1/2 inch, but there's a step to indicate the fan, and then I had to have room to cut it off of the main chunk, so I had to cut it back about 1.25 inches. So then I had to start machining the ID. So I went in with a 3/4 inch bit to start with, so I could get a boring bar in there. And after a lot of boring, I came up with this. So there's the step to indicate on the clutch, and then it goes inward, and that's where it's going to be the step to indicate where the fan bolts to it. And you can just see a little close up the step there. This isn't a very good picture, but I started machining out this side of the, this would actually be the side that would be facing the engine. The fan would sit on here, so I had to make a register for the fan to sit on to locate. That way everything rides true, keeps the balance good. A lot of cutting. And there I parted the two pieces out. So I was able to get rid of the big chunk. And then reset up with the spacer itself to do the final work on the receiver portion of it. And there it is, pretty much done. Of course, I still got to drill holes in it. Yep, a little bit too big. So this is the step that is going to indicate the fan blade, and then on the back side is the step that actually indicates the spacer to the clutch. So here you can see this clutch is down, the spacer is on, and then you can see that. Let me so you can see there's the fan clutch down lower. There's where the bolt holes actually are. That inside step locates on these registers here, and then moves the fan blade up a 1/2 inch, and then this register locates the ID of the fan blade, so that way everybody's riding true. And then I use transfer punches to put the dimples to drill the piece out. And here's with the fan blade off, and this thing is so sensitive. So there's where my holes were, and I went and drilled them. There's the side view of the step moving the fan away from the radiator support. And I don't know how, but I did not get a picture of it fully assembled. So when I go up to DNR tomorrow to work on the truck, I'll go ahead and get a good picture of that. So I was able to get that all finished up in one day. Unfortunately, using a hand lathe and you know, my lathe doesn't have a coolant tray and stuff on it, so it was a good portion of the day to machine that piece out. Plus the starting material was so big, just garbage can full of metal shavings to get that thing done. But I got her done, and you know, it's something you really can't buy, so you know, it is what it is. But we'll you know, move on from there. Tomorrow, hopefully, I was up last week. I went up last Wednesday, and I got the passenger side exhaust done back to the muffler. I got the driver's side done to the muffler, but then the skies opened up. Any of you guys in watch Florida weather, we've been getting inundated with rain, which we need desperately. We've been dry for months, but now unfortunately it's messing with my engine swap since I'm doing it outside. So, but yeah, I got that pretty well done. So I'll go up tomorrow, and hopefully with the weather is better, I'm going to go ahead and try to get the wiring finished up, and depending on what time it starts raining tomorrow, I will hope to prime the engine and maybe even light it off. So we'll see how that goes, but that's the plans for as they go right now. So we'll see how that works out. So working on the Cup car. I didn't get a lot of pictures on that because I'm kind of doing it in between other stuff. So, but I got the old transmission out. I thought I had a picture of the old trans, which is just an old Sagnal 4-speed. So that's out. There's the ACT lightweight steel flywheel. You can see they got lightning holes all around it, and in the center there. And there's the clutch. The disc guide to change the disc because this is a 26 spline and the Sagnal was a 10 spline. So we got a new clutch face there and got the throw-up bearing, just mocking everything up. Once I put the transmission in the car, I realized this shifter mount here is not going to work. The shifter's too far back, so I'm going to have to build that for next week. But I did get it up in place, and I didn't get any farther because I realized I had a show to do tonight, so I had to get some welding done to further our show here for welding. But making progress. I'll get some more pictures and stuff of the battery box and all the lead weights I made and all that stuff for next week's show. So the next thing we worked on this week was the 4200, obviously, trying to get that cylinder head finished up. So, kind of give you guys a, let's see, where are we at here? No, let's go back. So, if you guys have watched, you've already seen this, but for the people that haven't, here's the oiling system, oiling routing for the 4200 engine. And this one here with the yellow lines, that's the one that feeds the lifters. And we've had an issue with Leo's car that we were sticking the exhaust valves because there wasn't enough lubrication. So the Jessel lifters that are in this car don't have they don't have a oiling hole in them. Let me see, I can probably get you a picture of that real quick. Well, didn't want to do that. Okay, hang on 1 second here. Yeah, so the Jessel lifters don't have a oiling passage in them, so the oil isn't being squirted out of the rocker like it's supposed to be, which would then fling around the retainer and the springs and all that stuff. So we had to come up with some kind of alternate system. Where is our 4200? There it is. Yeah, so we've been working on that thing, trying to get that straightened out. And trying to see here if I got a picture of the lifters. Pictures of connecting rods and everything else. All right, I guess I don't. Maybe here's a. maybe.
Okay, so now
Nope.
we're gonna. Okay, so we'll use this manually fixture to drill the.
So yeah, so anyway, so I just scroll through here quick and see if I can find some. I guess I didn't have on that. All right, so anyway, so there's no oiling passes on the lifters, so the lifters are dry. So I came up with this idea, like they do on NASCAR engines and build endurance race engines, where we make a oil galley to go ahead and drip oil onto the push rods and stuff. So that's what I was starting with last week. Wow, sorry about that. Thought I had to. So yeah, so in the block there was this galley plug, so I pulled that galley plug out and I was able to make a piece that would go into there. And there's the galley plug out. That worked out pretty well there because it had a nice nice hole there for us to connect to. Then I went ahead and was able to make this system here, and so that should have worked out, mounted up real nice and everything. Alright, so here's a little video on what I was working on. So that was just using a hand pump, squirting some oil in there.
Alright, so
And got that all going. So this is our test. This is the test that I did today using the AccuSump to see how the oil goes. Alright, so my AccuSump set at 60. Got the fuel squirters all set up. So we're going to go ahead and, on my stopwatches, so we're going to see how long it takes for 1 quart to pass through. Let me set my stopwatch. Here we go. So it looked like it took 20 seconds for 1 quart to go through it. Of course, we're going through our the AccuSump, so it doesn't have a lot of volume going through a air chuck, but I think it's working. And I think we're going to go ahead and leave it like that. I was worrying about putting a restrictor in, but I don't think we need to. So when I was reviewing the video, make sure it was okay, and if I needed to edit or anything, couple of things that I didn't think about at that point. One, the system was empty. So all the passageways and everything, to all the lifters and everything, was completely empty. So that took some time to fill that up, which also, I mean, that's a lot of oil that had to be filled just to get the cavities filled before it could actually start running out of the lines. The other thing was I was getting a pretty good amount of oil out of the rear journals, but the front journals on the cam, it didn't see a lot of lubrication coming out of there. So re-looking at it and studying it and thinking more about it than just a quick, oh, see what it did. I am going to put a restrictor in the T to fill the lines. The other thing I want to do is I want to pressurize everything, and then redo the test again just to make sure that we have plenty of oil, but we're not running out of oil too quickly. The worst thing we want to do is fill the top end of the engine with oil. Now, the engine would normally not have any restrictor at all, and all the lifters would be squirting oil out at basically the same volume as our tube. A little bit more of a restriction there than just an open air tube, but basically still doing the same thing. And so we're gonna see. I'm gonna play with a restrictor, and we'll readdress this in another time, and run another test and see how that works out. But that's the newest update on the 4200. So far, I'm happy with the way it's all working out. Again, watching the video, the oil was kind of running out of the tubes pretty quickly in a stream. I was really hoping more of a drip, so I think a restrictor up there is going to help that out, just as long as we don't end up with no oil at the end of them. But we'll see how that works out. That's for another time. But that just get you guys caught up where we're at with that. So with all that said, we can go ahead and start tonight's actual conversation, MIG welding. So we talked about different kinds of welding last week. MIG welding is really good for production welding. When you need to weld stuff in a timely manner, fit and finish isn't quite as important if you were going to TIG weld something. But MIG welding definitely has its basics in everybody's shop. Obviously, most people that are starting off welding, they start out with a MIG welder. I did mention last week that you could also use a TIG and get a wire feed or a spool gun and use it as a MIG also. So, if you're starting from scratch, a TIG may be a better way to go, but there's nothing wrong with a good MIG welder. So, this is the welder I have in my shop. It's a Lincoln 180 amp. It's one that can be either ran on 220 or 110. I have it connected to 220. It's a good little machine. Still running all the stock cables and everything in it. You can get different length wire feed cables and stuff, but it's a good overall unit. Now, components that you're going to need. You need a ground clamp like this. Typically, when you purchase a welder, it'll come with a ground clamp. Think about, you may need to buy a secondary one because the ones that come in the clamp and the kit like this do not usually open up very big. And if you're welding large boxes of tubing or round bar, and you don't have an open end to clamp into, you're either going to have to weld a tab on, or you're going to have to change the ground clamp to something of a more substantial size that has a wider opening jaw. Another thing you can do is get a magnetic ground like this. You're welding steel, so it'll magnetically stick to steel, and then you can put your ground clamp on this, and then the jaw opening isn't as important. So on a MIG gun, or a MIG welder, you have a MIG gun, and it's going to be a cable like this. Typically, your more inexpensive welder is going to come with a 6-foot cable. My Lincoln came with a 10-foot, but you can get these all the way up to 25 feet. One caveat about the cable, though, is the longer the cable, the more finicky the wire can be running through the cable, because it's got to push the cable through all that length of cable. The way it lays is always a concern. My older welder I actually had a bar coming off the front of it to hold the first 6 inches of the cable up. You can see here they put a spring to try to keep the weight of the cable from making a sharp turn, because that can make the wire coming through the gun finicky, and you can melt the wire into the tip and create some problems there. So this is the parts of the gun that are consumables. If I can get this to go up. So this is your tube coming out of your gun. They have different shapes, and they have flexible ones. I'll show you one of them in a minute. And then you have the diffuser that screws into there. Now the diffuser is just just like it says. The gas comes up out through the cable and goes through the diffuser and comes out your gas nozzle, and that's what makes your gas bubble that covers the weld, so that you don't get contamination in it. And then you have a contact tip which screws into your gas diffuser, and this is what the wire actually comes out of. This is the part. The contact tips are what you're going to need the most of in your kit or in your toolbox, because these get all the spatter from the welding gets jammed up on here, and very possible that you end up welding the wire into the contact tip, and then it's done. So then you have to unscrew this piece, pull the trigger, run some wire out, cut it off, put a new contact tip in, and start welding again. One thing about that is, if your gas nozzle, again, this is a consumable, because this is going to get covered in spatter all the time. And you're going to sit there and beat it on the ground and take screwdrivers or dikes or whatever and try to get all the spatter out of it. And it's going to slowly wear down. When the contact tip comes close to the end here, that's when you get a lot more problems with your wire welding fusing to your contact tip. When it's deep in the gas nozzle, it's more protected and you have less issues with that. But you definitely should have gas nozzles and contact tips in your toolbox as spares. You're going to need those. Now, I mentioned a flexible neck. This is a flexible neck. There's your diffuser, and it doesn't have the contact tip in there. But this is nice because you can bend it to get around different shapes and stuff. When you're welding, especially like doing roll bars or welding maybe panels in a car, you can't get the gun because you're in a tight area. But you can get one of these flexible ones and bend the neck of the torch, so it gives you a good opportunity to get in there and get welding. And this is just some close-ups of your diffuser. This is way enlarged, but this is your contact tip. And this also, the thing I didn't mention before, you have to have a contact tip for every size wire that you run in your MIG gun. So I usually use 023, so I keep an 025 contact tip. I keep 2 or 3 dozen of them. I usually don't run any heavier wire than that because I don't do a lot of heavy duty welding. If you're welding heavy frames together or trailer hitches and stuff like that where you're welding 1/4 inch and thicker steel, you'll probably have to run a thicker wire, and you'll probably have to maybe even move up to a larger torch. But for what I'm doing, I like the 025, 023 wire. It's good for everything. It's a little small for heavy welding up to 1/4 inch, but it does get the job done. You just got to run a more wire speed and a lot of heat. And then this is your nozzle. And like I said, this top here gets beat up over time because of the spatter in the weld. See, Ryan says, funny you mentioned the cable. That's a pet peeve of mine with how it's stored. Yeah, you got to be really careful with them. Try not to get any bends in them, and I'll show you why. This is your cable casing. So inside your welding cable, this is what the MIG wire runs through. And so this is at your wire feeder, and then this goes all the way through your cable. So obviously this has to be as long as your welding cable is, the heavy duty cable, because there's gas that runs around the outside of this. So here is the part of your welding cable that goes into your machine, and you can see that there's holes here with O-rings. That's where your gas is going to go into the cable and go all the way up to the torch, and that's going to come out the diffuser. And this little step here is the end of your liner, and that's how the liner goes up again. That stop goes up against there, and that cable runs all the way through your torch, and it's going to end up right about here. So if you're replacing your liner and you buy a liner that's too long, when you hold the cable, when you hold the torch as straight as you can, you want to cut your liner so it just barely is inside here so that these threads can start. You don't want a gap between this and the liner because it's a place for the wire to get balled up. What happens if you get the welding wire to fuse in the end of this tip? Any gaps here or at your wire feeder, you'll get a bird's nest in there, and then you got to cut it all out and pull all the wire out. You lose all that welding wire, and then you have to drive new wire through and then start over again. And another tip for you guys is when you're refilling, you put a new spool in your machine, or you had to remove it because it got all messed up. You pull this piece out, you take your cup off, take the tip out, hold the cable in a straight line as much as you can, pull the trigger until the wire comes out this tip. Then you can feed it through your contact tip and then screw it all back together. You can't, the MIG wire will not self-feed through this piece because this piece is very close to the diameter of your wire. So you want to have it come out the end of your diffuser about 2 inches. Then you slide this over, screw it together, cut it to length, put your gas nozzle on, and then you're ready for welding. So if you're replacing your cable, I've done this on my older welders where I put a longer cable. You want to make sure what these dimensions are here and how your trigger assembly is set up. So on a MIG gun, you have a trigger button, and that trigger button is what makes the gas turn on and the wire feed start spinning. So you have to have this is the connector that goes back to the machine to feed the contactors from that switch. Again, there's the liner. So here's a 10-pound spool on my machine. Now on my Lincoln, you see they've got, looks like a liner here. Now this is part of the wire feed part of the machine. They're doing that so that That's guiding the wire into the feed motor. In here you've got a gear, and that gear will have a couple different grooves in it. You got to set the right groove for the wire that you're feeding. And then, so usually it's got a 025 and a 030, sometimes 032, maybe 035, depending on your machine. So you got to put that to the right piece or switch them out to get to the right piece so that you can feed the wire. And then this is the entry tip to go into your torch handle. So this tip are really close to the wheel, so that way the wheel, the filler wire doesn't have a chance to ball up in here when it's feeding correctly. This wing nut here is what loosens this up, and then you can pull the gun piece out. That's this piece here. This piece here, and then you see it's got a groove right there. So that groove is for this line here. This is your gas line going in. So this is a smooth bore here with O-rings. That's where your air goes, your gas goes in through the holes on the torch and ends up coming out the diffuser and then out your nozzle. And this wing nut tightens down, and that's what holds the unit into the front of the machine. Down here we have some electrode wires. So you have you see there's a plus sign there, and behind this is a ground. So since I'm running gas through, I'm not running flux core, I want to run it in a positive DC. So the negative, the ground goes to the negative side of the contactor, and this is the positive side. And all this is just where your voltage and amperage are generated to go out to the cables. And you can see this cable goes up and contacts into this brass piece, which is mounted in plastic. So it's isolated from the rest of the unit. So this piece here is hot with 12 volts, which sends the wire, the voltage through your liner out to your TIG torch or to your MIG torch, and that's how you get the voltage out to the to make the weld arc. There's just a close-up of the wire going through. The gaps on these is real critical if you have an older machine. Sometimes you have to play with these. You can loosen up these screws and move these in and out. But you can get, if your MIG wire is stopped, it gets stuck in the contact tip, this motor is going to keep feeding until you let go of the trigger. So what can happen is it'll make a bird's nest in here, and that's what I was saying. You'd have to take the whole thing apart, cut this off here, take the torch apart at the front, cut it off there, and then pull all that wire through. So if you have a 10-foot cable, a 20-foot cable, you're going to throw away all that filler wire that's in there, and then you have to make a clean cut on this side and refeed all the way back out to start welding again. So you really want to watch that, because it's a lot of wasted materials. The other thing is you want to turn your gas off, because with the gas on, you're sitting there holding the trigger, feeding all that wire, and it's only feeding at about 2-3 inch per second. It takes a while for it to fill 20 feet of cable. So turn your gas off so you're not wasting all your gas, and then remember to turn it back on before you start welding. Excuse me. So in the side of your most of your welding machines, inside the door, they'll give you this chart, and this is kind of just an approximate settings for you to start at. So you got your DC negative. So on DC negative, your ground goes to positive, and your torch is a ground signal, and that's when you're running the inner shielded or flux core wire. And then if you're running gas, like I'm running, it's a DC positive. So your ground goes to the negative side, your positive goes to the torch handle, and you want to use these settings for star gas, which is 75% argon, 25% CO2, or these numbers if you're running 100% CO2. And then if you're running an aluminum MIG gun, you run 100% argon, and it is DC positive also. Now the reason why you have to run a spool gun with aluminum is the aluminum wire is so soft, it cannot be fed through a long cable. So it uses this MIG gun. It's got the spool, the feeder is right here, and it only has about 2 inches to send the aluminum out the trigger, out the nozzle. So that's about the longest run you can run aluminum through a MIG gun. So no matter what kind of torch or welding assembly you have, when you're going to aluminum, you have to use a spool gun like this. Here they're giving you some tips on which way is the best direction to run. This is with flex core. You want to drag the welder this way or climb up the hill if you're doing a vertical weld. On inert gas, you run in this direction or downhill. Hi, Amy. And here, go and say hi. Wife wants to come and say hi.
Hi, Rick, and everybody else.
So yeah, so this would be for inert gas. Now you can actually weld either direction, but what they're doing here is your shield puddle is going to be coming out through here, so it's cleaning, kind of covering the metal before you get there. And when you're welding downhill, because you're pulling the gun away and the gas is inert, you can run it that way. And on MIG, you want to run it that way because obviously you're welding our aluminum spool gun. You want the gas to be covering where you're about to weld, not the weld that's already finished. So you definitely want to push forward in that direction. And then this is the chart. So you got your different gauges of steel, and you'll have a wire speed and a heat setting. And you can see that like an 025, they show it up to 10 gauge, 3/16. They really don't show anything more than that. It's a multiple pass is required. But that's not totally necessary. With practice, you can play with the speed and the heat, and you can do, I've welded a 1/4-inch plate, no problem with this welder without on a single pass, but just have to run the heat wide open and just try to get the wire speed going in the speed you need. It just takes a little bit of practice and you can get it. Now, because we're running inert gas, here's our gas setting. So we got our high pressure regulator, which is bottle pressure, and then we have this regulator here, which is going down here to the low pressure. This is what's coming out the gun. Hey, Chris, how you doing? Surprised got you in tonight. So, and then you have to set your regulator. We talked about this last week. You want to run about 20. If you're in an enclosed room, you can run it lower. If you're outside and there's a breeze or you have a fan blowing on you, you have to run it up higher. But you can hear when the welder is welding, and we'll get to that in a minute, and you can tell when the shield gas is covering the weld, and it's getting the weld proper. And there's what I'm running on my unit. I'm running Star Gas, which is the 7525. I was talking to Rick a couple weeks ago, and this is a really handy tool for welding sheet metal. This is a piece of copper with a handle on it. This actually came from Harbor Freight, but you can do all kinds of different stuff with this. With copper, you can buy a copper block or a copper bar stock, and you can clamp it or weld it, or clamp it or mount it to the backing of where you want to weld something, and you can weld against it, and the weld will not absorb or penetrate the copper. You can see here there's a little line here. This is where I had a piece of sheet metal sitting on here, and I welded it, and that's the residue coming out of the copper, but there's no penetration. That's just the other side of it. But they work really well. And when we get into TIG welding, I'll show you some stuff about back blocking, or where you put a big chunk of steel or aluminum or whatever on the back side of the material you're welding to pull the heat away from the metal, so that you can, when you're working on thin metals, so you can be uninterrupted. So if you can get go to a metal supply place where you can buy scraps, if you can get a chunk of copper, bar stock or flat stock, and you're welding, say, floor pans in your car, you could put that under the car and put a block of wood or a floor jack or whatever, and hold that copper up against your floorboard, and now your floorboards are kind of positioned where they're not moving around, but you can weld and it'll keep it from burning through. Works very, very good. This is just some pieces I was putting together. I didn't, like I said earlier, I didn't get a chance to get any cassettes to weld, so I just grabbed some stuff out of the bin. This is a 16 gauge, so this is kind of like a heavier sheet metal like you would have in a floor, or even in fenders and stuff on your older 50s and 40s cars, some of your 60s cars, before they started getting into the really thin metals. This is 14 gauge here, so that's 75 thousandths, and I just wanted to do some welds there. So this is the this is the 14 gauge sheet metal I welded. Tack, another tack to hold it together. I wanted to stop that for a second. So you saw this spot here, I'll go ahead and start it again, where it was spattering really bad. That's because I had my torch down, I'm wrapping, you should have seen this. I had spotlights and the camera on a tripod, and I'm kind of putting my arms around everything, trying to weld. Not the easiest setup. So the gun is too far away, and we don't have a good gas shield protecting the weld, so that's what makes it spatter like that, because it's getting contamination in the weld, so it doesn't want to weld till you get a good puddle, and then you can start melting the metal together. So you can hear this start spattering. So this is the 14 gauge 075 steel, 0.75 steel. So to make a good joint, you can make a couple passes, and this I'll show this later on, but this is a single pass where I just held the gun and went in a straight line, and this is where I did more of a C or a Z type shape, where you go back and forth, and you can see the white light here. That's where the wire is actually touching the metal and creating an electric arc. And this orange puddle here, watch that. That's the actual weld puddle. So that is where all the two metals and the weld metal are joining. That's what we're trying to get. That's how you get your penetration. If you're not getting the base metals into that weld puddle, then you're just putting a weld on top of steel, and it'll snap right off. So just kind of watch that as this goes, and you'll kind of get an idea of what's going on. Okay, so now I wanted to show you this. So this weld was that C or Z style back and forth motion. This one was just a straight pass. And right there you can see here's the arc, there's my weld puddle, but look at this piece here. There's no penetration to this piece of steel here. So that's the problem when you're just pulling the welder along like that, is you can't, it's hard to see if you're making contact on both components. So here you can see where the weld is worked in, dug into both pieces of steel. Here you can see it's dug in on this side and hardly any on that side, so that's a bad weld. That's why I prefer this. Plus you'll see this in a minute here when I turn it, you'll see it has the stacking dimes look that everybody's looking for. There you go. Now you can see the stacking of dimes, how it's going, and you can see the penetration better. See how it's digging into the steel there, the weld is? That's a good viable weld. This one's no good. This is the same thing. This was just a straight pass, and this is the back and forth. Now on that one I didn't get the filter turned back down, but you can see this one I was pulling the weld, this time I was pushing the weld, and you can see that if you have a good good gas shield over your weld puddle, you won't get any contamination in it either way. So this is 16 gauge galvanized. This is stuff I cut a long time ago. And obviously my saw was off because my miter cut was off because I got big gaps. So here, because I had a big gap there, you could see that I was trying to stitch it until the heat gets worse. So what happens is when you're welding, the metal starts absorbing the heat. And the longer you weld, the more heat it absorbs. That's one of the downfalls of a MIG, because you have your heat set at one temperature range and you can't adjust it unless you stop welding and adjust the machine. So that's when you have to start weld a little bit till you see it starting to fall out. Stop, let it cool for a second, go back in and stitch it together. And once the metals become closer together, then you can go ahead and finish the weld normally. Yeah, Chris, you have to work on getting a good lens. A helmet with a good lens is super important. I use one that is a variable darkness, so you can see out of it, and then when you pull the trigger, it gets the flash from the weld and then makes it auto darken, and you can adjust the darkness. But what you want to see is that puddle here. So when you watch these welds, you'll see there's going to be The white spot is the actual arc. That's where the wire is making contact with the metal, and it's arcing, just like if you're shorting two battery cables together. And then you'll see a yellowish orange puddle following that white light. That little puddle is your weld puddle. That is where you want to keep your arc moving in a position to where that little puddle follows you. If you start going too fast, you'll get away from the puddle, and it won't be able to keep up. So you just watch that puddle, and as long as it's moving with you, you can keep going. So I'm going to do a vertical weld here in a second. You should be able to see it pretty good. Of course, these welds aren't as clean because it's galvanized, and just FYI, make sure that you are not breathing the smoke coming off the galvanized steel when you're welding it. Try to do it outdoors, or if you're doing it in the shop, whether your doors are open or closed, try to get a fan to blow the smoke away from you, or use a fume evacuator, but most of us don't have that. But what I'm doing when I'm welding this is I've got a fan blowing over my head to make the toxins blow away from my face, so I'm not breathing it. That is a very bad chemical coming off when you're welding these. So see, Chris, and everybody else too, you got the white light here, that's the arc, and then you got this brilliant yellowish orange puddle. And watch, the puddle will follow the white light. That means my speed is correct. If the puddle is getting narrower, that means I'm going too fast. And if the puddle disappears because it's underneath the torch, you're gonna melt the metal and it's gonna make a big hole. But that's because you're going too slow. Now at the end of that, now on that, again, because it's galvanized, you won't see the stacking of dimes as well, because the galvanized is in the weld. The gas puddle cannot, or the gas purge over top of the weld can't keep the galvanized out because it's in the metal. So, but that, I hope you could see that puddle when I was going down. You could see it kind of yellowish, and it was kind of following the torch as I'm going down. Now, as I got to the bottom, I started getting the torch too far away from the metal, and it started getting spattery, and that's because the gas puddle, or the gas flume, wasn't covering the weld anymore, and it was getting contaminants in there. Rick says, if I recall correctly, you have to be very careful with brake clean products as well for cleaning surfaces welding. Yes, brake clean will off-gas some pretty nasty stuff. The best thing to use is acetone, but anytime you clean any of your products, and then while you got metal, you always want to clean all the oils off the metal. The galvanized, you can kind of grind it a little bit, but of course on galvanized, you're trying to keep it from rusting, so you don't want to remove too much of it. It doesn't come out looking great, but that's all right. As long as it's strong, that's all that matters. So here's another joint. Of course, you want to tack as much as you can, so that way it doesn't move. So here, you can see when I was at this part, how I was on and off the trigger. That was because, again, these pieces had loose gaps in them. It's not how you really want to build them, but they're just doors from my compressor house, so it's not that important. They're going to be plenty strong. But the metal will eventually get hot, and that's why it actually burnt through. I had to stop and then move to another section where it's cooled off and continue the weld, and then go back and close that up. But hopefully you can see the weld puddle that we're talking about. So I burned through, got to move over. Now I was too far away. Finally moved the cup closer, and then it started welding properly again. Fill my hole. Another vertical weld. So that was 16 gauge galvanized, and here's a very poor fitting piece. Unfortunately, I cut this stuff about 3 years ago when I was getting the building in shape, and the fixture on the saw was off, and I didn't have any more material, so we just decided to, I know with the MIG welder I can fill the welds, fill the gap, so we just went ahead and went with it. But if you're gonna really try to make nice pieces, that your fitment is ultimately the most important thing. With TIG welding, it is everything. Orion says, gotta bail. See you next week. Great topic. Thanks for the great info. No problem, man. Glad you were able to show up and get in next week's TIG. So the last thing I wanted to show you guys. I gotta go. Hang on a second here. So the last piece I welded was some 18 gauge steel. This would be like your newer car, your 70s cars, like floor pans and fenders and stuff like that. So, where's my... So that on your thinner steel, you have to stitch the welds because the metal's too thin to just pull an arc and weld across. You'll never get enough heat to get the penetration. It'll just keep blowing through. So it's much easier to spot and then keep going back and forth like I did on. That way you keep the warpage down to a minimum. You can see by the purple ring right here, I did end up with a lot of penetration. And when I flipped it over, there you can see that with the copper plate on there, the penetration came halfway through, but it didn't go all the way through. So that makes it work real well. I got some pictures of that. So here's a picture close up. Stitch it across, put the two pieces together. There's the back side, and you can see it's kind of bluish there, so it got heat in the metal, so it definitely bonded the two pieces together. And then I was able to grind the top side, and you can see there's a couple little spots where I didn't quite get, so now you'd have to go back over and fill them. But now you've got a well-joined piece that it's ready for body work or hammer and dolly, whatever you need to do to it. So that's the main thing I wanted to show tonight on MIG welding. Again, it's a cruder style of welding. Some people say MIG welding is easier. I find TIG welding to be easier because with the MIG, you've got the wire feed coming through the gun, and you really don't have time to study the weld puddle because you've got to keep moving. Otherwise, you get this big ball of a weld on your product, on the metal that you're welding on, because the wire feed is going, and if you slow the wire feed down, it starts popping and it's not welding good. So with a TIG, you can light the torch, you can get the weld puddle going, and then you dab your filler rod in. So when I show you that next week, you'll see that the whole weld puddle thing will probably make a lot more sense. And again, that's why to me say buy a TIG welder first, and you can do once you learn how to TIG, you can weld anything, because now you know what you're looking for, you know what is supposed to be happening. Another thing I didn't mention earlier, you could hear when I was welding, when the weld would be good, you could hear it sizzling like you are frying an egg. That's the way I always put it. And that's something to practice with. So when you hear that sizzle, you know the weld is good. You don't even have to look at it. So that's really handy, like when you're doing a roll cage in a car and you're welding on the top half of the bar around, and you really can't see where you're welding. You can kind of, before you pull the trigger, you can get your wire. You can kind of feel where the gap in the metal is. Line it up on there, pull the trigger, and then do your C or your V wiggle package, and follow that around, and listen to the sizzle. If you have sizzle, when you're done, you'll have a really good weld. Hopefully, you stayed on in the route you needed to join the two pieces together. I've done that before where I made a weld pass and it sounded great, and I looked back and I didn't even contact the piece next to me because I'm working in a blind situation. When you're working welding a gap and you're welding straight in, it's a little easier to stay on track. But even then, sometimes if you got a really tight joint and you got your weld shade made really dark, sometimes you can get off track there also. So just some things to do. But the big thing is get out in the garage, grab a bunch of steel, or like on Amazon, you can put weld cartridges or weld cassettes, and they have all these little boxes and octagons and stuff that you can buy that you can bend them together and then practice welding on. So welding is definitely a practice makes perfect situation. So keep practicing, keep working on your hot rods, doing, I know Rick's got some floor replacement he's going to be working on. You got rust hole patches you got to fix. You're making brackets or, parts to hold things in your car, a box to hold the fuel cell, brackets on the engine, and motor mounts and stuff like that, transmission cross members, boxing your controller and boxing your frame. All those things are going to require welding. So you want to get some like-sized welding material and practice, and then go to work. And remember, lots of tacks. The more tacks you can put in, the better it will be, because as you're welding, the heat's going to draw the components away. So if you don't have them tacked tight, they're going to pull away, and you'll end up with big gaps you're filling, and your metal will be all distorted. So, if you're welding a long weld joint, like you're boxing a frame, you want to put a tack probably about every 3 or 4 inches, and not a big tack, just one that joins the metals together. And that way, when you come back and you weld across, you can, everything will stay in place, and you'll make a beautiful weld. And again, when you're welding sheet metal, tack like every inch, and then go back and start at the beginning and work, do a tack next to the tack until you have all the spots filled. So that's it for that. We're going to get into some more of this stuff in the future. Next week, I'm going to show you TIG, and then hopefully by then I'll be at a point where we can get maybe the Vet Hawk in the shop. Well, I'll be building a battery box for the Cup car too, so we'll show actually some construction on how to build stuff and use the welding and cutting and all that stuff. We'll probably we'll do some bead rolling in the battery box and some brake action to bend some sheet metal. So that'll probably be in episode 103. So appreciate everybody hanging out. Again, we kind of ran a little over. I'm sorry about that. Hit the like button if you like this. Hit share to share with your friends. If you're not subscribed, subscribe. It's free. I know right now we're still running about 75% unsubscribed. That's fine, but it helps the algorithms if you're actually subscribers. Rick says, great stuff. Appreciate you sharing your knowledge. No problem. I wish I had more time in practice, because with trying to weld or work around the camera and the spotlights and stuff, it was kind of tedious. But I think it worked out pretty well. We got some pretty good weld puddle pictures in there, and hopefully I'll even get some better ones with the TIG. Hey Dave, what's going on? So, all right. So, guys, I'll see y'all next week. Appreciate you coming in and hanging out, and we'll see y'all later. See ya.